Welcome back, everyone, and thank you for joining me for part two of dynamic multi-point VPNs and building them in GNS3. So what I wanted to do is I just wanted to take a step back for a second and just go over exactly what we're trying to accomplish today. And the best way to do that is with a whiteboard. So please forgive me, I'm going to try my best to kind of draw the best way I can. So for all intents and purposes, we have two routers at the head office, right? And we have branches located at various locations across the country, and they need to get access back to the head offices. And what happens is that these branches are actually leveraging the physical, untrusted World Wide Web to be able to get to the head office. So, having done that, what we're going to do, and I'm going to show you in the configuration, is we're going to leverage the physical connectivity of the internet. And we're going to overlay on top of it a logical, virtual routing domain. It's going to be a VPN. It's going to be a dynamic multi-point VPN 100. Okay? As a matter of fact, let me just correct this here. But this router is the only one that's not going to be participating in the dynamic multi-point VPN 100. And the reason for that is because we're going to create some redundancy. And we are going to create another one. So 2 layers. So there's going to be 2 tunnels. There's going to be tunnel 100 and tunnel 200. And tunnel 100 is going to bring you to the dynamic multi-point VPN OSPF adjacency with the routers that are pertaining to DMVPN 100. And we're going to build one for 200. And they're going to be 2 separate dynamic multi-point VPN solutions. And we're going to create it in a way in where 100 is actually chosen as best. And in case that one goes down, 200 can pick up the slack. And the third part of this video is actually going to go through the troubleshooting techniques of how we can actually see it in action. So stick with me. Hey guys, welcome back. Let's get going with the configuration portion of part 2 of building dynamic multi-point VPNs in GNS3. So, moving along as promised in the previous video, just to reiterate, we decided that we want to build on top of this physical topology. Okay? And what we're wanting to do is we want to leverage the physical topology, the physical layer, to build an encrypted VPN routing domain. Actually, we're going to build 2 encrypted VPN routing domains. Okay? Now, this is a very simple setup, and believe me, this can be done many different ways, so feel free to modify the configuration, design, or topology to meet your needs. Okay? Now, the whole premise of dynamic multi-point VPN is the fact that it leverages IPsec. IPsec is the tool used to encrypt the GRE tunnel, which is called multi-point GRE. Now, if you don't know what IPsec is essentially a framework. It's a suite of protocols that combine together ensure secure data communication across an IP network. So protocols such as data confidentiality, DES, or AS, right here, data integrity like MD5 or SHA, authentication, whether it be pre-shared key or the RSA, are combined together to allow secure communication over untrusted networks, such as the internet. So now that we know what IPsec is and that it's a suite of protocols used to establish a secure VPN connection between 2 or more remote networks, we need a protocol that will handle the exchange of these parameters. And that's what ISACAMP is. ISACAMP stands for the Internet Security Association and Key Management Protocol. It's what's used to help exchange these parameters. But in addition to exchanging these parameters, we need another protocol called the Internet Key Exchange that's going to help handle the security associations in an attempt to create the VPN tunnel. So there's many different layers in here, and there's many different things going on. But every single line of the config is accounted for, and we need to know exactly where we are when we're configuring. So having said all this, what I'd like to do is I'd like to just copy and paste the configuration, and then in the subsequent video, we're going to troubleshoot and play around with it, okay? So let's just go ahead. That looks good. I like it. I like it. Now the tunnels 100 and 200 are going to go down, but that is expected. Branch 1, configuration for branch 1. Let me just add to this here. There's no harm in doing the OSPF portion as well. Let's do branch 2. So just bear with me here. I'm trying to do this as fast as possible. Looks good so far. Oh, we got one adjacency up, so that's really good news. Let's try number 3 here. Oh, can't grab it. There you go. Alrighty then. So that looks good. Oh, we got a nice little adjacency there. Let's go back to branch 1 now and finish it off with the second one. Didn't like it. Let's just make sure. Trying my best here to capture this guy as well. Oh, we got it on there. That looked pretty good to me. Branch 2, yeah. Let's see if adjacency goes up. Boom, that looks good. Looks like we're in really good shape. Let's not jinx it. And this is the last of them. So in the next and last video that I'm going to make, we're going to do a test to see if it all works. So end, show IP OSPF neighbor. Look at that, all full. Show IP OSPF neighbor. Oh, it didn't create one with, I think I know why. All right. Yep. Okay, so branch 1 makes sense because it's like that. This one makes sense. And this one's having a hard time. So let's just take a look really quickly at what could be going on here. Yeah, and it looked like it didn't take that command. Oh, tunnel 200, not tunnel 100. So there you go. I may have gotten lucky here. Let's see if it pops up. It should be coming up here. I may need to reinstigate the tunnel. Oh, that didn't bode well. And there you go. So all 3 of them are up. So we have basically 2 separate encrypted routing domains, and I'm going to prove that to you in the next video. All right, thank you.